What is network scanning? Network scanning is a process to identify and map network devices. A network scan discovers available IP addresses. It identifies device types such as servers or routers. Scanning detects open ports on devices for potential vulnerabilities. The process helps in planning network maintenance or upgrades. Here's a simple explanation. Imagine you are trying to find all the houses, devices, on a street, knowing where they are, what kind of house it is, e.g., residential, commercial, and if anyone is home, i.e., if certain doors or ports are open. That's essentially what network scanning does, but for devices on a network. It helps you plan maintenance, upgrades, or even troubleshoot issues by knowing what's there and how to reach it. Benefits of network scanning. Network scanning is a process to discover and identify devices on a network. Identifies active devices and potential security risks. Helps in configuring network settings and optimizing performance. Facilitates the discovery of new devices joining the network. Enhances overall network visibility and management. Here's a simple and clear explanation. Think of network scanning like using a map to explore your neighborhood. Just as you want to know what houses are occupied, who lives there, and if anyone new has moved in, network scanning helps you understand what devices, like computers or phones, are connected to your network, which ones are working properly, and if any new ones have joined without your knowledge. This gives you a clear picture of your network's neighborhood and helps you stay on top of its management. Preparation for scanning. Gathering and organizing necessary information. Identify devices to be scanned. Determine scanning protocols and methods. Ensure necessary permissions are obtained. Plan for potential scanning risks and mitigation. Here's a simple and clear explanation. Getting ready for scanning. Before you start scanning, it's essential to prepare by gathering and organizing necessary information. Here are some key steps to help you plan smoothly. Know what needs scanning, identify which devices, documents, or equipment need to be scanned. Plan the approach, determine the best scanning protocols and methods for each item. Get permissions, ensure you have permission to scan any sensitive or confidential information. Anticipate challenges, think about potential risks and challenges that may arise during scanning, such as damage to devices or data loss. By taking these steps, you can ensure a smooth and efficient scanning process. Choosing the right tools. Choosing the right tools is essential for effective network scanning. Network scanners devices designed to scan networks. Protocols support consider SNMP, SSH and Telnet. Device compatibility ensure scanners work with various devices. Power source options choose between battery or AC powered scanners. Here's a simple and clear explanation. Choosing the right tools for network scanning. Just like how you need the right screwdriver to fix a loose screw, network scanning requires the right tool to get accurate results. Imagine trying to measure the temperature of your house with a thermometer that's not designed for your specific type of thermostat. You wouldn't get reliable readings, would you? The same principle applies to network scanning. Using the wrong scanner can lead to incomplete or inaccurate information about your network. So, when choosing a network scanner, consider the following. Protocols support. Does it support SNMP, SSH, and Telnet? Device compatibility. Will it work with all types of devices on your network? By selecting the right tool for the job, you'll be able to get precise information about your network, making it easier to manage and maintain. Understanding network topology. Network topology refers to the physical or logical arrangement of devices and connections in a network. Devices are organized into different layers. Hub switches and routers are key components. Wired and wireless networks have distinct characteristics. Topology affects network performance and security. Here's a simple explanation. Network topology. Think of your home as a small network with different rooms, devices, connected by wires, connections. Now imagine these rooms can be arranged in different ways, like a floor plan. In a wired network, each room is directly connected to the next one with cables. In a wireless network, all rooms are connected without any physical cables, like a big neighborhood where everyone's devices talk to each other. This arrangement affects how your network performs and stays secure. Just like how a well-designed floor plan makes it easy to move around in your home. Network mapping and visualization. A process to visualize network structure and relationships. Visualizing network connections. Identifying potential vulnerabilities. Mapping network topology. Creating detailed network diagrams. Here's a simple explanation. Network mapping and visualization is like drawing a family tree, but instead of people, you're showing how different computers, servers, or devices are connected to each other on a network. Imagine you're trying to plan a road trip across the country. You'd want to see all the roads and highways that connect different cities, right? Network mapping does the same thing, but for computer networks. It helps you understand who's talking to whom, where the data is flowing, and if there are any weak points or potential problems in the connection. Identifying devices and services. Identifying devices and services is a crucial step in network scanning, enabling you to pinpoint specific nodes or resources on your network. IP addresses, unique numerical labels assigned to devices or services. Port numbers, specific communication endpoints used by applications or services. Service names, identifiers for specific network services such as HTTP or FTP. MAC addresses, unique identifiers for physical network interfaces. Here's a simple explanation. Identifying devices and services. Imagine you're at a library with many shelves and books. You need to find a specific book. IP addresses, like shelf numbers, e.g., 123, 456, IP addresses are unique labels for devices or services on your network. Port numbers, like specific book titles, e.g., The Great Gatsby, To Kill a Mockingbird, port numbers identify specific communication endpoints used by applications or services. Service names, like signs above each shelf, service names, e.g., HTTP, FTP, are identifiers for specific network services. MAC addresses, like unique shelf labels, MAC addresses are unique identifiers for physical network interfaces. Think of it like a library where you need to find a specific book. Each item has its own identifier, a shelf number, IP address, a book title, port number, and even a unique label on the shelf itself, MAC address. Scanning techniques and methods, a systematic process to identify network devices, services, and vulnerabilities. Active scanning. Passive scanning. Vulnerability scanning. Network mapping. Here's a simple explanation for each scanning technique. Active scanning. Imagine you're at a party and you want to know who's there. You start calling out everyone's name, one by one, until someone answers, or not. Active scanning is like that, you actively probe devices on your network to see if they respond or not. Passive scanning. Now imagine you're still at the party, but this time you just listen carefully to the conversations and observe what's going on. You don't call out anyone's name, instead, you let them interact naturally. Passive scanning is similar, you monitor network traffic without actively probing devices, letting them communicate normally. Vulnerability scanning. Think of a vulnerability scan like inspecting your home for potential security risks. You check locks, windows, and doors to see if they're secure or vulnerable to break-ins. Vulnerability scanning does the same thing on your network, identifying weaknesses in software, hardware, or configurations that could be exploited by attackers. Network mapping. Picture a map of your neighborhood with all the houses, devices, connected by streets, network connections. Network mapping is like creating that visual representation, it helps you understand how devices are connected and where they are on your network. This can be useful for planning, troubleshooting, or even just getting a sense of what's going on in your digital neighborhood. Types of scanners and tools. Network scanning tools and techniques used for network discovery. Network scanners, tools that discover devices on a network. Port scanners, utilities to identify open ports on devices. OS detection tools, programs to determine operating system types. Vulnerability scanners, software to detect potential security risks. Here's a simple explanation. Network scanning tools. Imagine you're trying to find all the houses on a street where you've never been before. A network scanner is like a map that helps you discover which devices, houses, are connected to the network. Port scanners. Think of ports like numbered doors on each house. Port scanners check which doors, ports, are open or closed on each device, helping you understand what services are running inside. OS detection tools. These tools are like asking a neighbor about the type of heating system used in their home. They help determine the operating system, Windows, Mac OS, Linux, etc., of devices connected to the network. Vulnerability scanners. Picture a security expert checking your house for potential safety risks like unlocked windows or weak doors. Vulnerability scanners do similar checks on network devices, identifying possible security weaknesses that need attention. Network vulnerability assessment. Identifying and prioritizing potential security risks in a network. Unpatched or outdated software vulnerabilities. Weak passwords or poor account management. Misconfigured firewalls or access controls. Unsecured network devices or peripherals. Here's a simple explanation. Network vulnerability assessment. Imagine your home network is like a small city with many interconnected buildings, devices. Each building has its own security system, firewalls, passwords, etc. If one of these systems is weak or poorly configured, it can create a vulnerability that allows an intruder, hacker, to access the entire city. A network vulnerability assessment is like conducting a thorough review of each building's security system to identify potential weaknesses. This helps prioritize efforts to fix issues and strengthen overall network security. For example, if your home network has an outdated router with known vulnerabilities, a guest account on a laptop with a weak password, a network printer that's not properly configured, a vulnerability assessment would highlight these risks and help you take steps to address them, making your home network more secure. Port scanning and port usage. Port scanning and usage are methods to identify open ports on a network. Scanning for open ports is crucial in detecting vulnerabilities. Closed ports are secure but open ones can be exploited. Open ports can indicate compromised or misconfigured systems. Identifying unused ports helps in optimizing resource allocation. Here's a simple explanation. Port scanning and port usage. Imagine you are trying to find a specific door in a building. If all the doors are locked, closed ports, it means everything is secure. But if some doors are open ports, it could indicate that someone has access they shouldn't have, or that there's a problem with how the building is configured. Why is this important? Just like identifying an open door can help you fix issues in a building, scanning for open ports on a network helps you find vulnerabilities, protect against unauthorized access, optimize resource allocation by closing unused ports. By understanding port scanning and usage, you can ensure that your digital doors are secure and functioning properly. OS detection and fingerprinting. Identification of an operating system through unique characteristics. Identifying OS types Windows, Linux, Mac OS. Detecting security patches and updates. Gathering information about installed software. Revealing network configuration settings. Here's a simple explanation. OS detection and fingerprinting. Imagine you're at a coffee shop and you connect to their free Wi-Fi. As soon as you do, your device starts sending information to the coffee shop's network about its operating system, like Windows or Mac OS, security patches it has installed, what software is running on it, and even its network configuration settings. This process is called OS detection and fingerprinting. It's like a digital business card that reveals details about your device, which can be used to target you with ads, malware, or other unwanted stuff. Just like how some coffee shops use your info to offer you deals based on what they know about you. Identifying open ports and services. Identifying open ports and services on a network. A port scanner is used to detect open ports. Open ports can indicate malware or unauthorized access. Scanning can reveal running services and applications. This information can help in security and threat assessments. Here's a simple and clear explanation. Identifying open ports and services. Imagine you are trying to find a specific restaurant, service, that's open in a neighborhood. You can't see inside, but you want to know if it's operating. A port scanner is like a tool that helps you look at the neighborhood network. It checks which doors, ports, are open and which services, like restaurants, are running behind them. Why is this important? If a door, port, is open unexpectedly, it might mean someone has access they shouldn't have. Scanning can reveal which services, applications, are running on the network, helping you prepare for security and threat assessments. Think of it like getting a list of all the restaurants in your neighborhood that are currently serving food. You can then prioritize visits or further investigation based on the results. Network configuration and security. Network configuration and security refers to the setup and protection of computer networks. Switch ports manage switch ports for network access control. Firewall rules implement firewall rules for network traffic filtering. Encryption protocols utilize encryption protocols for secure data transmission. Network segmentation segment networks for improved security isolation. Here's a simple explanation. Network configuration and security, protecting your network. Imagine you are hosting a big party in your home, and you want to control who enters and what they can access inside. Switch ports, it's like setting up separate doors, switch ports, for guests to enter through. You can choose which door, to open or close to control who gets in. Firewall rules. Now, imagine you have a bouncer at the entrance who checks each guest's ID before letting them in. Firewall rules do something similar, but for computer networks. They filter out unwanted traffic and only allow authorized access. Encryption protocols. When your guests give you their personal info, like name or phone number, you want to keep it secure. Encryption protocols work like a safe lock on sensitive data, protecting it from prying eyes. Network segmentation. Picture your home with separate rooms for different activities, e.g., a kitchen for cooking and a living room for relaxation. Network segmentation does something similar. It divides the network into smaller, isolated areas to prevent unauthorized access or data breaches. By configuring and securing your network in these ways, you can ensure safe and controlled access for all users. Network device identification. Network device identification is the process of identifying devices on a network. The use of network scanning techniques to identify devices. Device identification for network security and management purposes. Identifying devices such as printers, routers and servers. Discovering and mapping network topology and infrastructure. Here's a simple explanation. Imagine you are trying to find all the computers, printers, and routers that are connected to your home internet network. Network device identification is like creating a map of who's on your network and what they are. Think of it like this: when you invite friends over for a party, you want to know who's there and what they brought, like food or drinks. Similarly, network device identification helps you see which devices, like computers or printers, are connected to your network and what kind of role they're playing. This information is useful for managing and securing your network. Device discovery and enumeration. Discovery and enumeration of devices on a network. Scanning for active IP addresses. Identifying device types and vendors. Gathering system information and OS versions. Detecting open ports and services running. Here's a simple explanation. Imagine you are trying to find all the devices connected to your home network, like computers, phones, and printers. Device discovery and enumeration is like creating a map of who's on the network. This process involves finding all active, turned on, devices with IP addresses. Identifying what type of device each one is, e.g., laptop, phone. Figuring out which operating system, like Windows or Mac OS, each device uses. Seeing what services are running on each device, like a web server. Think of it like using a network scanner to find all the devices connected to your home Wi-Fi, then looking at each one to see what's running and who you're sharing with. Malicious activity detection. Malicious activity detection involves identifying and preventing unauthorized access or malicious behavior on a network. Monitoring for suspicious traffic patterns. Analyzing logs for security-related events. Implementing intrusion detection systems. Utilizing threat intelligence feeds. Here's a simple explanation and real-world example. Malicious activity detection. Imagine you're at a coffee shop with free Wi-Fi. Someone tries to access your email account without permission, which is malicious activity. Malicious activity detection helps prevent this by monitoring for suspicious traffic patterns, analyzing logs for security-related events, using intrusion detection systems, and staying up to date with threat intelligence feeds. These tools help identify and block unauthorized access or behavior on a network.